All right, Mr. Ahmed here for 2.2. We are going to work on inductive and deductive reasoning today. This video will be a little bit shorter than the last one, so we'll get rolling here. So, a couple definitions. A conjecture is an unproven statement that's based off observations. And we are going to use inductive reasoning to make this statement just by looking at patterns. When we make the conjecture, we're going to look for a pattern. We'll list some examples out, perhaps. We could draw a picture to see what we see, and then we will write that conjecture based off what we notice from our observations. So the first one's kind of done for us, and it talks about the pattern of 10 to 4 to -2 to -8. So when I look at this pattern, I can see that it's going down by 6 each time. So the pattern is subtracting 6. The conjecture would be each number is the previous number minus 6. And our next item would be -14. So when I look at the example that's not done for me, I have to think to myself, how do I get from 1 to -2? Well, there's a couple ways. I could subtract 3, but that doesn't follow the next one, because -2 minus 3 is not 4. So that's out. I could times by -2. 1 times -2 is -2. -2 times -2 is 4. 4 times -2 is -8. So the pattern I see is that we're timesing by -2. So my conjecture would be each number is the previous number, I'm going to use a number sign, multiplied by -2. So that is my conjecture. So the next item would have to be -8 times -2, which is 16. All right, the sum of two odd numbers. So this one doesn't have a list out. So this is a case where I should write down some examples. So if we add two odd numbers, something like -3 plus -5, that's equal to -8. 5 plus -3, that's equal to 2. -9 plus 11 is equal to 2. So the pattern I'm seeing is when I add two odd numbers, I am getting an even number. So my conjecture will be the sum of two odd numbers is an even number. And I just use a number sign to speed up the process there a little bit. All right, next page. It says point S is between R and T. So this one I should draw out a picture based off what I see. So point S is between R and T. So I have R, I have a T, and somewhere in between I have an S. So the conjecture I could make off this, I can't really say these are equal because it didn't say it was a midpoint. So I'm going to use the segment addition postulate and state that RS plus ST is equal to the whole thing RT. And that would be my conjecture. Counterexample is used to determine if a conjecture is false. So to show that a conjecture or an idea is true, I have to show that it's true for every single case. It has to be true no matter what. But for me to show that it's false, I just need one counterexample. And that counterexample is a specific case where the conjecture is false. So just one thing. So this one says, find a counterexample to show the conjecture is false. And the conjecture says the sum of two numbers is always greater than their difference. The sum of two numbers is always greater than their difference. So okay, let's try this. Let's go 2 plus 6 equals 8. Okay. 2 minus 6 is equal to -4. So did that work? I would say in this case it is true because 8 is greater than -4. Now I need to find one that's false. Let's try -3 plus -6. That's -9. -3 minus -6 is equal to 3. So this shows that it is false. I have found my counterexample to prove that the conjecture is false. And that is my specific case where it is not true, because I took two numbers. Their sum was less than their difference. Okay? Deductive reasoning uses facts, definitions, or accepted properties, and the laws of logic to form a logical argument. So I'm not really looking at a pattern in this case when I use deductive reasoning. I'm going to use some factual arguments and just specifics to show that something is true. And the two main ones we're going to use are the law of detachment and the law of syllogism. Okay? The law of detachment states that if the hypothesis of a true conditional statement is true, then the conclusion is also true. So it says, if two segments have the same length, then they are congruent. You know that BC equals XY. So if that's the case, if they are equal, then they have to be congruent. So I know that BC is congruent to XY. And another example of this could be if it is raining, then it is cloudy. Period. I know it is raining. So this would be another case where we could see something like this come up. Now, when you see some of these problems, take it for what it is, okay? Don't try and argue it. There could be some specifics here or there where it might not always be true, but just take it for granted. And in this case, it says if it's raining, then it is cloudy. It is raining. So since it's raining, I know, I'm going to write this in different colors so it stands out, it is cloudy. That is what I can infer. All right? So that's pretty straightforward. If the hypothesis is true, then the conclusion is also true. Here with the law of syllogism, this one's going to involve two statements. So when I see these two statements, one of the hypotheses has to match the other's conclusion. So in this case, this hypothesis is Q. This conclusion is also Q. They say the same exact thing. If that happens, I could form a new statement by saying, if P, then R. All right? So one of the hypotheses has to match the other's conclusion. So in this problem, we have the first example. It says, if a polygon is regular, then all of the angles of the interior polygon are congruent. If a polygon is regular, then all of its sides are congruent. So I see the matching piece. It says, if the polygon is regular, if the polygon is regular. However, in this case, those are both the hypothesis. So I cannot write a new statement using the law of syllogism. Okay, there's nothing to write. I'm done. It's not possible. The hypothesis of one statement does not match the conclusion of the other. So I added one more where this will work, okay? So the one that I added, you could write this one down if you'd like for an extra example. It states, if you practice, then you will get better. If you get better, then you will win the game. So the one that matches is, you get better, will get better. Those match. So my new statement will have to be, if you practice, then you will win the game. So these two matched. I form my new by taking the leftovers, okay? So my new statement will have to be, if you practice, then you will win the game. And that's using the law of syllogism. These matched, formed the new. One of the hypotheses has to match the other's conclusion. All right, that's all we got for today. Have a good one.